solve this differential equation. This is a homogeneous one, and then we'll apply y of 1 equals 2. So first we have to break this up into the following. dy dx is equal to x squared over xy, and then plus y squared over xy. That's allowed because you have the same xy. Now look what happens. Simplify this. So dy dx would be equal to the following. Cancel off x. So it's going to be x over y, like that. And then for the second one, cancel off a y. So you're going to have y over an x. Now we have the issue, which is this right here, this term, this is x over y. We need it to be y over x because we wanted to make it homogeneous. So we can do that by writing this as dy dx is equal to 1 over, and then just write that as y over x. Because 1 divided by y over x is equivalent to x over y by the properties of fractions. And this is plus y over x. V is equal to y over x at this step. That's the key step, really. And then you can recreate the equation, well, this part right here, as vx is equal to y. But remember, this v is like a function of x. It's like v of x. So then you can form a y prime. And then on vx, you have to use the product rule for derivatives. In other words, it's going to be vx prime this way. Remembering that it's really v of x. So you carry that out, the product rule is v prime x plus, and then the derivative of x with respect to x is 1, that goes away basically, and then you copy the v. So it's v prime x plus v. Since v prime x plus v is equal to y prime, in other words, we have the following. dy dx is equal to v prime x plus x. But now remember that we wrote dy dx as 1 over y over x plus y over x. So we can write dy dx is equal to 1 over, and then y over x gets replaced with v, plus, and the other y over x also becomes v. But we also know that y prime, which is in other words dy dx, is v prime x plus v. So we can equate the two. We're going to say 1 over v plus v is equal to v prime x plus v. So I'm going to write dv dx times x plus v, just to be more suggestive of the correct symbols. And then you can do, let's see, 1 over v plus v minus v. So move the v from the right to the left for subtraction. So you get then dv dxx. And then the v's will cancel. So you're going to have 1 over v is equaling to dv over dxx. And then you can just cross multiply and separate the variables. That's the whole purpose of doing this process. So you're going to have, therefore, let's see, dx over x, depending on how you choose to see this, is like a proportion. Dx over x is equal to v dv. And then you can anti-differentiate, so you're going to anti-differentiate dx over x, right? And then you're going to anti-differentiate here with the equals between the v dv. So when we do that here, it's going to be ln of the absolute value of x is equal to 1/2 v squared plus c. Now that we have this, we can write ln of the absolute value of x is equal to 1/2, and replace v back with y over x. And then this is squared, and this is plus c. And then now you can apply the initial condition where it says y of 1 is equal to 2. So you're going to have ln of the absolute value of 1 is equal to 1/2. And then this is going to be y. So it's going to be here, let's see, 2 over 1 squared plus c. Then you solve for c. So ln of 1 is 0. And this is equal to, let's see, now it's going to be 2 squared, which is 4. 4 divided by 2, which is 2 plus c. Capital C, that is. So now you're going to end up with 0 minus 2. So negative 2 is the value of c. Which means the implicit solution is this one right here, essentially. Ln of the absolute value of x is equal to, let's see, 1/2 of y squared over, you have to be really careful here, x squared, correct, minus 2. Now here it happens that we can actually solve for the value of y explicitly. So you're going to do ln of the absolute value of x, and then plus 2 is equal to all of that 1/2 with the y squared over the x squared, and then multiply across by 2x squared. So you're going to have 2x squared within parentheses ln of the absolute value of x plus 2. This is equal to y squared. When you take the square root here, you're going to get a plus or minus. So you have to be careful with that. Remember, our initial condition is y of 1 equals positive 2. So y has to be positive and not negative. So you're going to have y plus the square root of 2x squared, x squared here, and then the ln of the absolute value of x plus 2, and apply the roots. So you're going to have x square root of 2. And lastly, we can write this as y is equal to x, and the square root of 2, and then ln of just x without the absolute value bars plus t. You don't need the absolute value bars. You really on your own should graph the solution. You will see why you don't need the absolute value bars. I'll leave that as a mystery for you to figure out. Do you see the like?